Hello, my name is James Liu.
Hello, my name is Erica Parker, and we are representing Perkins Eastman. Today we're going to present our breaking through concept, G.I.S.M.O.
So what is G.I.S.M.O and what does it stand for?
G.I.S.M.O is Guidance for the Impaired, Sensory Monitor, and Operator. G.I.S.M.O is a system that creates an adaptive environment using artificial intelligence. Its technology assists and guides physicians in the diagnosis and treatment of sensory impaired individuals with a variety of conditions.
The concept of G.I.S.M.O pushes the boundaries by creating environments that would otherwise be considered impossible and reimagines what the patient experience could be inside of a typical medical facility.
Sensory disabilities have many causes and some are unknown. If they are not diagnosed early and treated, it can lead to developmental delays. G.I.S.M.O is able to observe patients subtly using artificial intelligence. G.I.S.M.O captures these patient problems when they first appear before the patient's exam. G.I.S.M.O addresses the stress levels of the patient and uses data to determine and anticipate their needs.
So now we're going to take you on the patient experience of Anna as she goes through her typical checkup visit to the doctor.
So every morning, Anna wakes up and she has difficulty getting dressed. Anna is moderately deaf and has profoundly low vision, and she suffers from color deficiency. So after getting ready and unable to see her outfit, Anna becomes deeply upset, and she knows she's on her way to see Dr. Vu. So here we are now in the facility, and you can see Anna and her mother holding hands. Anna relaxes as G.I.S.M.O senses her presence and brings up her patient profile. G.I.S.M.O then changes shape to match her existing patient preferences. G.I.S.M.O's panels begin to undulate and change shape into a handrail that adjusts perfect for Anna's height. The handrail illuminates with her favorite colors and ignite her sight and touch sensibilities. And so here you can see Anna grabbing on to the handrail as it walks her down the hall, and she playfully runs her hands across the surface of the vibrating corridor walls.
Now let's take a closer look at how G.I.S.M.O works. The dynamic infrastructure of G.I.S.M.O is composed of thousands of microscopic pins that are coded to read and adapt to a variety of patients.
And here you can see how G.I.S.M.O physically undulates and molds to any shape prompted by an individual. G.I.S.M.O creates a bespoke environment on its own as well in a response to an individual's needs. These micropins within each panel have the ability to transform into an infinite amount of configurations.
The animation displayed in the previous slide showed how G.I.S.M.O can adapt in order to anticipate a patient's needs, some of which are shown here, such as handrails that can assist with accessibility when going upstairs, experiential corridor that can morph to assist as well as entertain, and seating that is adjustable and ergonomic to the patient profile. To tie micropin movement sensors and data together, G.I.S.M.O is activated by tactile sensory input. The pins are created via a blend of AI and machine learning technology.
When the micropins activate, they do a variety of interesting things, such as emitting sound and light, collectively changing shape, expanding and contracting, all while collecting and storing data. So now let's see where Anna is in her experience. So while she's waiting for the doctor to conclude with the previous patient ahead, G.I.S.M.O rearranges its panels and forms interactive gaming experiences. Anna gently touches G.I.S.M.O's panel sensors and unknowingly begins her visit as the sensors collect her information on her audio and visual capabilities.
As Anna or any other patient moves and interacts with G.I.S.M.O, it passively engages and captures data to form a complete profile.
The patient profiles are comprised of the individual and their medical devices. So G.I.S.M.O can store a deep and extensive database in a large network bank that can be used to diagnose and treat other patients, expand healthcare research, and advance medical practices. So Chapter 2, the exam room. So as Anna enters this exam room, she immediately runs towards this reflective screen full of color. She smiles intensely at herself while G.I.S.M.O helps her see in full color spectrum for the first time. Now you can see Anna in the main exam room, and you can see the mesh screen as it projects custom 3D shapes while sounds emanate from the surrounding contours.
So to explain the concept behind the exam room a bit, the concept really emerged from the primitive idea of man's first environment, which many designers consider to be a womb or a cave. A typical one-size-fits-all exam room is not really suitable for all people. As a result, much like the corridor, the exam room has the capability and capacity to expand and contract to meet individual patient needs. Some of the highlighted elements in this room include sound and the light, which is emitted through the micropin panels while physicians read the patient reactions to the reverberations and noise. Comfort and calmness. In this example, we push the boundaries of what could be considered a typical examination seating. As the patient leans into the micropin contours, the pins will then expand and contract around the patient, creating an area that will provide comfort during vital monitoring and data collection. Last but not least, two-way vision for the physician to evaluate and observe the patient while diagnosis is taking place. G.I.S.M.O utilizes the maximum capacity of AI as a way of replacing initial physician interactions. The use of this AI technology in this setting aids the physicians as they're able to passively observe and possibly diagnose their patient before even needing to touch them.
So now let's jump in and take a look at where Anna is at now with her exam. So Anna lays back on the exam table as it forms around her. G.I.S.M.O automatically knows her weight and asks to take her blood pressure. You can see here she's smiling at the ceiling and she can see the ocean and sunset. Chapter 3, Diagnosis. So here you can see Dr. View as she uses G.I.S.M.O to observe Anna's real-time response to the room. Afterwards, Dr. View and her team of specialists are pleased to inform Anna that she will be receiving a new hearing aid. However, she'll have to return for one more follow-up visit in order to get her glasses and have them exchanged for the G.I.S.M.O custom device. In the end, Anna is able to plug in a new hearing aid and listen to her mom perfectly. And they both share joyful tears as now you can see Anna is enjoying the G.I.S.M.O experience in the outside world. Chapter 4, G.I.S.M.O devices. So before Anna leaves the facility, Dr. View has her try on a test pair of glasses. She lets her take these glasses home for a test trial in order to track visual progress and collect more data. So G.I.S.M.O's applications and the infinite possibilities. So not only is G.I.S.M.O adaptive in a medical setting, we really wanted to experiment and push the AI and microprint technology concept in other world settings and have it scaled beyond impaired sensory and monitoring.
For example, when the G.I.S.M.O is applied in a public park, it can adapt to create individualized seating. When it's applied in public civic spaces, G.I.S.M.O can be applied to the corridor walls to create integrated handrails that are supportive to the individual. When G.I.S.M.O is applied at home, the panels can be applied to the walls to respond to the user's needs and store the data that is paired with their devices.
So now let's jump back in and see Anna's final scene. So relaxed and content from her life-changing visit this week, Anna smiles and sits down to read at home with her refined glasses. Her spectacles automatically illuminate and help her see the words in her book. And we appreciate all of you for allowing us to share our vision for the future of healthcare design through Anna's experience.
Thank you.
Thank you.